Hello everyone. Today we are going to make this project plant pathology, that is identify the category of foliar disease in apple trees. Basically in apple trees, okay, we have four kind of categories: healthy, multiple diseases, rust and scab. Okay, so basically if you go for overview, you will find that like what's the problem statement. So this is the project which we are going to make. Just download the data set. Okay, I think it will ask you to participate in competition, something like that. So just do. And so see, what we are going to do is basically this is your original data set. Okay, this is the data set right now. This in this, what is the problem is the test images and the training images are given together. See the training, okay, and about testing, and their labels are given in a CSV file. So its labels are given in CSV file. See the train and the test. So our main task is to first of all combine them. Like of course, see, if training and test labels are given in a separate CSV file, okay, and their images are given in a folder. So how we gonna work? First of all, we need to prepare our data. See, we have four categories: healthy, multiple, rust, and scab. If you like train 0 JPG, okay, this JPG in that image, it has scab, okay, that's why 1 scab 1. If you have multiple diseases, then 1 here. If you have rust, then here it will 1. If you are healthy, it will show 1. Okay. So you can see here, like in the images, okay, like this. If you go for the training, and you can look, okay. So let me just show you this train 0. What is this train 0? Okay, the labels are shown here in the train. It has scab. Okay, it has scab. This train 0.jpg, this lips has scab. So we need to train our deep learning model to recognize them. Okay, so our main task is to prepare our training data. So what we are going to do is, see, we are going to separate these four categories. Okay, like of course how to give x and y to the model. Okay, so what we are going to do, we are going to separate them. Okay, the photos of the healthy in the healthy folder, the photos of the multiple diseases in the multiple diseases folder. Similarly for rust and the scab. Okay, see the train 0, this is in the scab folder because it has scab. Train 7, train 8, train 11, train 44, like that. Okay, then easily our model can see, once we divide them, then using image data generator, and if we give class mode is equals to categorical, our model will easily see, okay, this folder contains four subcategories, subdirectories, means these are the labels: healthy, multiple diseases, rust and scab. Then we will no longer need this CSV file. Okay, we will no longer this, because once our folder are categorized, our model will easily see, okay, these are the categories. Okay, and the test, we don't need to uh, categorize them. Okay, so that's is our problem statement. So let's start making the project. Okay, and if you find this video useful, like, subscribe and hit the bell icon. Okay, let's do this. Okay, so let's start the coding. First of all, as always, we're gonna import some libraries like NumPy. How to install all these libraries? Okay, just Google it. Like it's simple. Just write here, in, including exclamation mark. Okay, so that this Jupyter can understand you are giving a command. Okay, pip install pandas, pip install NumPy, like this. Okay, so if I press shift plus enter or run, it will say requirement already satisfied because I've already done installation. Okay, so that's how you're gonna install it. And uh, okay, it's recording. Okay, import OS. Okay, like see, as I posted in my Instagram, from this from this project, this particular one, I have studied, I have learned so many things. Okay, like it's one of the best projects I have ever made, and using this four very basic library or function which I'm going to introduce, I have solved the data preparation part. Okay, like see what I need to import now. Import shuttle. Okay, like import shuttle, and one more import nets short. This four library. Okay, it was like a game changing for me to prepare the data, because as I said, how's our data? See, in like this. Okay, uh, yeah, so like this. Okay, see the images of test and train. Okay, and its labels are here in the CSV file. Okay, train and test, train and test. I have not signed in. See, train 0 in that particular folder. So train 0 is scab. Okay, as I have explained. Okay, train 1 is multiple diseases. Train 2 is healthy. Okay, so our data set is in images and its labels is in CSV file. So we need to merge them both. Okay, we need to merge them. So these four libraries have helped me a lot. Okay, a lot it has helped. So now let's import from PIL. Oh, sorry, from PIL I'm gonna import image, and all right, and import matplotlib dot pyplot as plt. Okay, now TensorFlow time. Okay, from or directly let me import TensorFlow as TF. Okay, because yeah, later on we will make, when we will make our models and all, then we will do this. Okay, or we will import this later, but it's up to you. We will import many things later on. Okay, import image. Oh, it's, I think it's capital I. Yeah, so image. All right. Other things of TensorFlow like layers and all, we will import it later. Okay, so our data preparation, data importation part, sorry, library importation part is completed. Let me, from tqdm, just import tqdm. Okay, yeah, one more thing. All right, so where is our directory of, where is our directory of what happened to this cell? Where is our directory of images? Directory, I'm just giving dir as a name. Images original data set. Yeah, see, so let me give this name. Okay, so this is our image directory which we will need soon. Okay, so I'm just importing it. So this is our images folder, and now let's import the labels. Okay, the labels. So train is equals to pd dot read csv, and just give the path. Okay, paste it. Python takes everything in the forward slash, so this just put r. Okay, and give here name train dot csv. Okay, and just copy paste this and paste this here and name this test. pd dot read csv, this and test dot csv. Okay, so there you go. So now train dot head, and see, this is your train, and test dot head, this is your test. Okay, what is head? Like top 5, top 5 it will show by default. Okay, let's open and like let's try to open an image. Okay, image, I'm giving image open name. Okay, so plt dot matplotlib dot im, or okay, I think first of all we need to let's just open one image here. Okay, image 1, I'm just giving image 1 name, image that capital IMG from where we have, from the PIL library, image dot open, just give any, just give the path to any image, like let me just copy paste this, and let's open here train ARAIN and the zero top train, okay, like the train 0.jpg, or test you can also do. Okay, let's open this in the Jupyter itself, test, okay, this image, okay, this .jpg, and there you go. But just one more thing, tlt dot, it will open it, and of course we need to show it now. So I am show this image 1, show it here, okay, here you go. To remove this line, okay, like the basic information, just get it also. All right, there you go. Okay, so now see, what we need to do is, see, we have 4 categories, right? Healthy, multiple disease, rust, and scab. Okay, and see, but in the train, if I talk about the train here, okay, I talk about this train, this is test files, and if I go down, this is our train, okay, train. See, in train, okay, in train, see, test folder we will make separately, but we will not categorize it, okay, we will only divide our training files into 4 categories, okay, into 4 folders. For escape, there will be a different folder. For rush, there will be a different folder. Similarly, for healthy and multiple diseases. Okay, so we are not going to make different folders for test. Okay, testing we do on the same folders. Of course, the model should predict the unlabeled data. Okay, unseen data. Model should predict, but it will train on the labeled one, of course. Okay, if you know basics of any machine learning, like basics of machine learning, the ethics of machine learning. Okay. Well, all right. So see, we don't know, na, like this. What is this train 66 looks like? It is looking like healthy. Okay, to me, train 67 is also looking like healthy. This is looking like I guess scab or multiple disease. This is looking like scab. Okay, so let's, like, here we have given the labels. Okay, train 1 file having multiple diseases. Okay, so what we're gonna do, we're gonna make separate folders. Okay, so for those leaves which having multiple diseases, that all the images, like all the images of that leaves which having multiple diseases will be in a folder named multiple diseases. Okay, so let's make it. So class names I'm giving, train, our training file. I hope train.loc. We want all rows, like, see, we are calling from, see what, so see, first of all, what we need to do, we are going to make another column named label. Okay, and what it's gonna do is basically, see, it's gonna be a simple thing that we are going to make another column named label. Okay, to make our data preparation little easier. If it's healthy, it's gonna label it as 0. If it's having multiple diseases, it's gonna label it as 1. If it is having rust, okay, then it's gonna label this row as 2. And if it is scab, then it's gonna label it as 3. Okay, it's simple. So those here files which is having healthy, which are healthy, okay, it's gonna label it as 0, 1, 2, 3, like this. Okay, according to number wise. So first of all, let's have that classes name. Like we have 4 classes, right? Healthy, multiple diseases, rust, and scab. And we want for all the rows, like this is the basics of Python called slicing. Okay, all rows, and we want from healthy. We don't want image ID column name. From healthy, we want till last. Okay, till last. And what we want, sorry, let me just okay. And what we want the full column names. Okay, columns. All right. So let's let me silence my mobile. Sorry about that. All right. Okay. So let's print another mobile. All right. Let's print the class names. Class names. There you go. Okay. These are 4 class names. And now let's write a program to make another column named label according to these 4 columns. Okay. Number is equal to 0. Just a little mathematics. That's all. What I can say. Okay. Train. See how to make another column. It's simple. Basics of pandas. Label. See, this is our training. This is our train file. Okay. CSV file. Just write another column named as label and give it, initialize it as 0. Okay. So your train data will look like this. See, now you have another column as 0. Okay. So for name, I'm just giving a name or for I, a global rule. Okay. For I in class names. Okay. This I will go for here, then here in the rest, then scam. Okay. For I in class names. Okay. What we want, it should do its looping like train and see. Just write with me right now. Train label is equals to, see, right now it's all 0 0 0. Okay, in labels. But for I in class name, see, if it's healthy, the I is equals to healthy, then train label gonna be 0. Otherwise, if it's multiple diseases, then it's gonna be 1. If it's rush, gonna be 2. If it's scab, it's gonna be 3. Okay, scab. So yeah, train label is equals to train label, train level plus train date. Oh, sorry, train I. Okay, whatever its row into number. That number which we have initialized as 0. It's like that label column. Okay, the row right now it's 0, all 0. Okay, so for I in class names, if it's healthy, then the train label gonna be train label plus the I. Okay, that 0 to index you can say, into the number, if you do some bits basic multiplication and all, you will get it, and number is equals to, every time it will increase the number. Okay, number is equals to number plus 1. So now there you go. I think I have done it. All right, let me do this, and here you go. See, now see here. Okay, the train 0 is having scab, so it's label 3. Why? Because this is 0, this is 1, this is 2, this is 3. Okay, so multiple diseases 1, rust 2. Okay, and why it's 0? Because healthy is 1. Okay, according to numbers it has labeled. Now we just need this label and this image ID. That's all. We don't need other things. Okay. So now let me shorten this. Here you go. Okay. So now prepare. Let's do next step. What? Prepare training data. Okay, like we were just doing, it's pre-process, okay, but not a pre-process is not a valid term here. Okay, because we were doing preparation for data from the starting basically. Okay, I think I should name it here. Prepare the data. Prepare the training data. From here we have started. Mark it down. Yes, alright. So we have given here and let's make a function called get label image. Okay, I'm just naming a function. It's gonna be image. Okay, I'm just giving a parameter name img, which gonna stands for the images. Okay, so I'm making a function get label image. What it's gonna do? It's gonna go into all the files train 0 and it's gonna get its labels like 3. For train 1, the labels gonna be 1. Okay, so it's gonna extract the labels. That's all. So now if this search, okay, this search we are going to use right now. Okay, what this search do is simple. If search, it's what it's gonna do, it's gonna go into this file. Okay, and it's gonna search the term as train. What this search do is shift plus tab. If you do shift plus tab in Jupyter notebook, you will find that you need to give pattern and the string. String means the, you can say where, like this image you need to give. Okay, the images basically. So what is the pattern? It should be written as string, because in this file we have like so it's gonna search this train. Okay, I'll explain you more. This train, wherever the train is written in that image folder of images and in this CSV file. Okay, yes, I know that train.csv contains only train, I know, but just wait. Okay, so you're gonna search for the train, and in the all the images, like this image is basically gonna run in the loop, like first in this image, this image, this image. So image name is img. Okay, so for every img, you're gonna search for the train, and if it's like if search train, okay, if it's true, how if else for true false in the basis of true false. Okay, if it's train, then what it's gonna do? It's gonna split it like how, see, on the basis of dot and select the first. Like, see, let me explain you this. Okay, before we go forward, let's say our this is our image. Okay, img equals to train 66. Okay, train 66 dot jpg. Okay, this. So now if I do image dot split on the basis of this dot. Okay, so it's gonna make a list like this. Okay, so it's gonna split like this, and now if I do like the zeroth element, this, okay, zeroth index is gonna only choose this one. Okay, so like that it's gonna split. Okay, it's gonna split and it's gonna extract the extract the labels. Okay, so what the label for this train 66 is gonna look here. Okay, it's gonna look here, and whatever is gonna be like for train 01, for train 0 only. So for train 0, the label is 1, not here, sorry, you can see here it's 3. Okay, it's 3. So it's gonna take that label. Okay, it's going to store in it. So train dot loc lock or dot lock. Okay, dot lock, and under that again it will take two things. Okay, train image id, equals to image, and it's gonna take the label. Okay, take the label. Okay, so it's like train.loc. So for the every image id, okay, it gonna take the label. Okay, so let me run this and let me erase this too. All right, and yeah, one more thing, return the label. Okay, return the label. All right, so now let's create the last function, you can say, that is training data. Okay, we have written a function for the labels. Let's do it for the training data. Okay. So let's make another function called create uh, create the training data. Okay, create data train, and that's all. So see, this function we will use under this function. Okay, so so now see, images, all the images, okay, images, and see what's our directory name. This is our directory name, right? Yeah. So wait, just give me 1 second. uh, mm, mm, Original data set. All right. So see, images is equals to net sort. Under net sort, we have a function called net sorted. Okay, net sorted, and what it's gonna do? See, we need to give dir, but we need to give one more thing here. What it's gonna do? See, this our directory of images. Okay, but see what happens here now is, see what, like what's the problem here is, if I do os dot list of directory list dir, and if I give this directory, okay, if I give this directory, and see, if you will find a list of files, 0, then 1, then 10. Okay, test2 is not there. See, in the ascending order, test2 is not there. Okay, test 3, test 4, directly test 10, test 100, test 1000. But in our labels, okay, in our labels, you will find them in the very chronological order. Okay, like this is a training thing, and let's see now, like if I directly go down, and you can't find that. Okay, but let me just directly, just for an example, okay, test. Let me log in here, but all right. See, test 0, test 1, test 2, test 3. Similarly, for training also you can see, right? Train 0, train 1, train 2, train 3. Okay. So see. So what's we gonna do is, like, see, we can't see for training because of course it's very long queue, and the Jupyter does this. Okay, like it won't show you full everything in the under this directory, but what does this net sorted do is simple. Okay, uh, see, net sort dot net sorted. Okay, and if I give this one here like this, then see, then now it's gonna be in a chronological order. Okay, uh, test 0, test 1, test 2, test 3, test 4, test 5, like this. Okay, so this is a very unique and so not unique but very useful function to do sorting. Okay, so see, so here net sorted, and let me delete this. All right, so net sorted dir. Okay, and for img, that this img will go to all the images. Okay, in images. Okay, so see, what is this images? That sorted one. Okay, let me, okay, one more thing here, we need to write os dot list, the list of files in that directory. Okay, this list dir, do that. Okay, so this this img, see, understand this, it's very easy. Okay, this img, or you can write I also here. Okay, if you are not able to understand j or whatever. Okay, so this img, okay, I have given a variable name. This img will go to this, in this images. What is this images? The list of all the images in a sorted one. Okay, so img gonna be this, img gonna be this, img gonna be this. Okay, img gonna be this, like this. Okay, or if you get confused between this img and all, you can write j, k, l, anything. Okay, for img in images, okay, it's gonna extract the label. Okay, it's gonna extract the label, get this get label, oh, sorry, get label image, and this img. Okay, so get label image, and from that image, okay, from that image img like train0.jpg, get its label and store them into the label variable. Okay, so for every image in that the batch of images, it's gonna extract the label. Okay, and one thing we need to define is path. Okay, the path we need to combine, we need to add, or you can say we need to merge the directory, the list of images, okay, the like this directory with the images itself. Okay, like see, we are now accessing to the directory, but we need to work on the images, like we need to take that. Okay, so let's join that folder and under that images. Okay, like I hope you understand the this thing, os dot path dot join. Okay, dot join the dir, okay, the directory of images with its own image. Okay, and give the path. So now this path contains, what does this path contains? Like see, this is your directory. Okay, this is your directory, this is your directory, and the path gonna be, and see, this is your image. Okay, so if I do this, okay, if I do this, okay, if I do this, so the path gonna be like this. See, this is your directory, this is your image img, so path gonna be like this. Okay, like see, full path to the image train0.jpg, full path to the image like this. Okay, so yeah, as I say, I explain each line of code in a very basic way. Okay, so yeah, so now you have full path to the image. Okay, now here search the train, here search the train. Okay, into every image search it. If if you can say, if image that every image and split them. Okay, first of all split them on the basis of underscore, like I'll tell you. Okay, don't worry, and take the first indexing. Just let me explain. Huh? Okay, let me explain. And take then dot and the 0. Now what does this it's mean? Like see, this is your image, this is your image. Okay, so dot split, and on the basis of underscore, so it's gonna split it like this on the basis of underscore train0 then 0.jpg, and it's gonna take the first one, means this one or this one, this is the 0, this is the first, this. Now on the basis of the basis of dot, okay, take this one 0th one, means in the train, in the all the images, okay, everyone has its unique id, like train0, train1, no two files are of same name. Okay, so now it's simple, right? No, train0 is only, train0 is unique, train1 is unique, train120 is unique, because it's no two files are of same name. Okay, so now if this 0, okay, like the image file name in the train, okay, that all the files which in that images in that images, okay, in this original dataset images, okay, all the files which are having name as train, because it's going to search for train, and the train0, okay, this train0 and label dot item, the item of the label, okay, item of the label is equals to 0. Okay, means what does it means is, if its image is 0 and its, and oh sorry, if like whatever the name of the image is, okay, like right now it's 0, and if its label is equal to 0, and what does it means? If what is the label? 0 means healthy, okay, label 1 means multiple diseases, label 2 means rust, and label 3 means scab, okay. So if the image name, if its label id is 0, okay, so shuttle dot copy this into copy this, okay, like see what this shuttle means, okay, this shuttle, it takes the source and the destination, okay. So copy the file, that image, okay, copy that image, and what is the image path? The path itself, okay, the path itself, like right now the path is this train 0, okay. So copy the train 0 from this path, okay, and paste it, let's say it can make its own directory, okay, like let's say you can also make, okay, it's up to you, images, and I'm giving this path, I'm just gonna copy this, okay, and images healthy, just give it name healthy, it will make healthy folder named healthy by itself, okay, after like just one line of code, it will make healthy. So if the image name and whatever the image name is, okay, if its label is equal to 0, take that image, okay, and copy this into, take this image and just copy this into this, okay, just paste this into healthy folder, okay. Else if I'm just gonna copy this all, okay, I'm just gonna copy this all, okay. Else if whatever the image name is, okay, if its label is equals to 1, copy that and paste this into multiple diseases, okay, I'm naming say multiple underscore diseases, I'm naming it same as the column name, okay, like it's up to you, but I hope you are getting, okay, like if its label is equals to 1, paste that into multiple diseases folder, okay. Similarly do this for both, I am giving, as I said, I am giving same name as column name itself, okay, like using underscore and all, just oops, rust and scab, ooh, scab, and 0 1 2 3, okay. So image name, if its label is 3, just put this into scab, okay. Else write one if and else you don't need to write in the else, but just write if, else search for the train test, search for the test, like it has only two, right, train or test in that images, okay. Search for the test, like in the all the images, if that image contains name test, okay, like what is the search function do? Pattern and a string, like what's that, the file name, you can search the file, okay. Search it and copy this into shuttle.copy. I'm just gonna copy the oops, no, don't reload. Let's copy this oops, copy, I think, yeah, all right. So for the apple trees, and copy this into, let me edit names, images, and name, make one folder called test, okay. As I said, we are not going to categorize the test data, okay. The test data is the label, the unseen data, okay, not the label but the unseen data. So all right, test, I think we are done. Invalid syntax, else search, Oh, sorry, not else but elif. Yeah, of course else doesn't take, no? So elif. All right, else doesn't take any argument. So if or else if it's test and do this, else folder not found, you can do this. Okay, so now after this you need to make folders. Okay, like so subtle function do same, OS can also do dot make directory. Okay, you need to make 6 directory or 5, yeah, for healthy multiple rust scab and test. Okay, you need to make 5 directories. So I'm just gonna copy this path and there you go. Okay, so make directory and oops, healthy. Okay, in the images we are going in the images. um Actually let's do one more thing. This is images now. Yeah, so I'm just adding one more layer here. Okay, in the images it's gonna be train. Okay, under images it's gonna be train. Under images it's gonna be train then scrub. Okay, I think I have put it, in the image is gonna be train then healthy and only test. Okay, so first of all make train. Okay, first of all make this folder named as train. Okay, then make train, and like we have already made train, and after the train folder is existing, make one more folder named as healthy. Okay, similarly we are going to make folders, some more folders like healthy, then for multiple diseases, for rust, for scab. Okay, so for multiple diseases I'm just gonna copy this name and there you go. Okay, then for rust and for scab. Okay, for scab, and the last thing is we need to make for let me direct, or let me put it here. Okay, test images, then make one more folder called test. All right. Okay, see, it has made 4 folders. Okay, like this. Right now it's empty, but it will get fulfilled. Okay, test. See, for the training, this 4 folders. Okay, 4 categorized folders. Now let's run that function. Okay, this function. Let's run this function. Okay, this one. Create data, create train data. Okay, and it will add all the images into its their own thing, their own directories. So train for train datas or train datas. Should I, what should I name my variables? Train datas. Okay, train datas or train batches or train categories. Okay, train categories. Train directories would be a better name. Train directory, and run that, this create train data and run this. Type error. Destination I am missing in the train. Here I am missing the destination. Subtle dot copy. Yeah. Of course, subtle dot copy path. There you go. Okay. See, one error you are going to get. Like I just ran this cell now after writing your path. I'm again going to run this. Okay. But here I will get error, file exist error. Why? Because these folders already exist. So we are running this cell, we are running this cell again. So you will get this issue. What you can do, if you again need to make folders, just delete those 2. Okay. So there you go. Now it has already, it now again made it, and now okay, the program is running. Create train data. It's running. I think I forgot to apply one function. See, it is running. Okay, I forgot to apply one function, but I'm sorry for that. Okay, let me delete this before showing anything to you. Like images are there, okay, but I forgot to apply one thing which I imported, that is TQDM. Okay, TQDM. What is TQDM? You know, like it shows progress bar. Okay, like just to make things you know, little detailed. Okay, so TQDM for IMG in images. Okay, TQDM. Okay, just put TQDM here, the images, and just in the bracket. So now make this again and see, now it's a progress bar going on. TQDM is a very beautiful thing. I said this in a live project. Okay, like someone asked me what TQDM, and I said it's a very beautiful thing. So lame jokes. Okay. All right. See, this is our original dataset, but apart from that, now we have test files, all this, and now we have our train categorized healthy, train 2, train 4, train 5. You can cross check here now. Okay, so like it's train 2 is healthy. Okay, train 4 1 healthy, train 5 1 healthy. Okay, train 9 it is having 1 means it is healthy. So see, you can see train 5, train 9. Okay, then all the healthy. Then similarly multiple diseases, rust and scab, train 0, train 7 and all. Okay, so 592 images here, rust is having 622, multiple diseases only 91, multiple diseases is having only 91 images. Okay, healthy 516, so it's a very imbalanced data, but what we can do right now. Okay, so test train data part is ready. Okay, now we need to make model. Like data part is ready. Okay, model, what should I name it? Models or model preparation, model preparation. Should I name it this? Preparation. I'm very bad at spellings. Okay, so yeah, it is done. Our folders of images are ready. Let's make model, deep learning model. Let's start training. Okay, okay, before going into the depth of model preparation, okay, we need to do what? Okay, before going to model preparation, let me do this and let me, all right. So we need to do what? Data pre-processing. Sorry, pre-processing. Okay. Data pre-processing. Mark it down. Now, what does it means? Okay. See, every image size is different. Like even if I go there or anywhere. Okay. Every image size is different. See, it's 2048 cross 1365. First of all, it's very big. Okay. The small the size of the images, the better it will be for the model to converge. Okay, okay, so see, and see its dimension. Okay, like yeah, it's good that their dimension are same. Okay, the dimensions are same, but it's very large. Okay, so let's try to reduce the dimension size, means the size of the images. Okay, like it's right now it's, you can see that it's 2048 cross 1365. Let's try to reduce the size. Okay, and we have like dir, or but not in dir, but let's do what? dir or um, train dir, oops, train dir. Let me zoom in. Train dir is equals to, okay, train dir is equals to, let me give this train. Okay, so this is our train dir. Okay, train directory. Okay, under that you have 4 subdirectories. Okay, so train and now all right, so let me put it here only. And categories, what are the categories do we have? Categories. Okay, what are the categories we have? Okay, we have healthy, we have healthy, all right, we have mul multiple um, diseases. Okay, we do have rust, and we have scab. I could have write class names, right? But all right. So for I in, or for, okay, I is already used now. So let's use J for I in, or and IMG is also used, so it's of no use. For I in categories, okay, categories. For in categories, this, sorry, for J in categories, this J will go here, here, here. Okay. What is the path? Again, we are initializing the path. OS dot path dot join the train directory. Okay, join the train directory with J, means this J. What is this J? First of all, it's gonna be healthy. So join this training directory, this train folder with its J, means under training directory we have healthy, we have multiple diseases. Of course, in the train directory we have healthy, multiple, rust and scab. Okay, so join them and and do operations on their images. Okay, their files. And what is the file? Their images. Okay, so for IMG, means again we are giving this name IMG, or you can give K, L, M and OP. For IMG in OS dot list of directory, this path, means what is this path right now? What is this path right now? Like we just did now, this path as like this. Okay, uh, okay, so categories might be not defined. Okay, let me run this once again, not once again, but let me run this and see what is this path right now. This na, the project Foliar disease and images train. Okay, then this is the path, the last path right now after we ran na. So the last path. So now what we are going to do is we are going to do some operation like on that, like in OS dot list of the files in the path. Okay, what happened? OS error is incorrect. How is incorrect? Um, like in my previous code I have given like this, so no problem. Okay, train rustscape for list of path directory. Let me check, guys. Okay, so I didn't found much, like let's keep writing, I'll figure that out. Okay, I didn't try to solve. So see, for J in categories, path equals to os dot path dot join. Okay, for then this, for IMG in this list of directories, the path, and what is the path right now? This, right, scab. Okay, means the last one. So I'm just giving an example. Okay, this path is basically this healthy, the multiple is full path to rust, full path to scab. So for J in categories, this J went to healthy, then multiple diseases, then rust, and then scab. So right now it's scab. Okay, so it's gonna go into the loop. Okay, it's gonna do this process with the loop. Okay, first it's gonna go for healthy. So in the healthy, okay, for IMG, for that image in the listed in this function. Okay, list dir of path means all the files into the path. And what is the path? The first path is healthy or Jane category. So the first one is healthy. For all the images in healthy, CV2. Okay, I think I have not. Yeah, I think yeah. So import CV2. Sorry, CV2. Okay, I have not done. So CV2 means open CV. Okay, open CV CV2 dot im read every images. Okay, read every images means os dot path dot join. Okay, and what is path right now? The folder till the healthy. Okay, so healthy, and under that what you have? The images. Okay, so img. Okay, img and first of all convert this into cv2 dot color. Okay, color bgr, cause OpenCV takes everything in a bgr color, so it's gonna make it greenish. Okay, bgr to rgb. Okay, first of all take every image. I am show. Let me show you. Okay, and yeah, first let's image array. Okay, is equals to, then let's call that same here array, and plt dot show. Okay, so let's display this, and oops, yeah, same, I'm getting error. Okay, train healthy. Categories, path dot join. Training directory with its categories is okay here, according to what I have written. File name directory and volume is in the file name of projects, Foliar repositories, images. Under that we have train. I think is this is creating some problem, I guess. I don't know. Yeah, I think I should put R. And takes, yes, this is all. I am read takes 2 arguments, 3 given. Oh yeah, I think I given pad dot join 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 sorry join path with image. Okay, beginners who are watching this, have patience. Okay, I solve everything. So join the path means this healthy folder with its images. Okay, convert that into bgrc. All the, if you don't do this, now let me interrupt this. Okay, let me interrupt this. If you don't apply this, then what gonna happen? Let me just show you. See, like, see, I think you might notice, but uh, don't you think it's changing color little bit? Okay, I might be wrong also here, but it's always better to have some like images. Okay, so break and break the loop, like just show the first one. Okay, so this is the image. Okay, like I just loaded an image. Okay, after converting into BGR to RGB. Okay, the 3 channel, and now what we are going to do is, see, this is our image array. Like I have given a named image array, or you can give anything. Okay, so image, this is your image array. Like the first one we are showing just the break. Okay, otherwise all the images, like see, if I remove this again. Okay, so see, all the images are getting loaded. Okay, so now we are going to resize them. Okay, we are going to resize them, like I am just showing you the first one. Now we are going to resize them, and how it's gonna look, I'll show you. So image size, what we're gonna do, we're gonna give image size is equals to its experiment now. Okay, some people give, like, you might you will see a data set which is having image size 28 cross 28. Okay, 28 cross I think Amini's data set of handwritten. Okay, see, it's 2000 cross 1365, 2048 cross 1365. Amini's data set I think only have 28 cross 28. Okay, like Amini's handwritten disease data set. Okay, so let's define image size 28. Okay, new array. Okay, new array or new image, or the old image, should I give it like this? I hope new image array or image old image. Before image resize, what should I name? New image. Let me give it new image. New image. Okay, I'm just giving the name. Okay, new image. cv2 dot resize them. Resize them. All the images, that is image array. Okay, and see, cv2 resize takes this argument, source, the image array, and the size. Okay, so convert them into 28 by 28 means I have already given image size. Okay, so 28 cross 28. Okay, so plt dot im show new image and plt dot show. See, now just think about that. Okay, just think, just look at this and think, will your model ever gonna recognize this? Like, what is this? Okay, like, I'm not even able to say that this is something like leaves. Okay, like I can't even say this. Okay, so even your model will not able to recognize. Like, of course, if we can't able to recognize, your model will not. Okay, like, if this is your image size, so for every data set your image size will vary. Okay, let's take it to 50, little bit. Okay, but just think about that. Is scab is visible? Is multiple digits or whatever? Do you think is it's gonna be visible here? No, right? So let's increase it to 80. Still not. It should look clear, okay, because it's very small. So let's take it to 150. Okay, 150. Can I take it to 24, or it's up to you? Okay, like, now it's okay. Okay, 224 or 300, 400, whatever you want to give. Okay, but don't give it like this is a standard what we say in the VGG 16 architecture also. I think 224 if I'm not wrong. Okay, 224, or you can even try 200. Yeah, not much difference. Okay, so let's take the standard word 224. If you search what's the standard image size, you will find mostly like this. Okay, so see, all the images gonna be now 224 size. Earlier it was 2000 cross 1365. Okay, 2040 cross 1365. Now it's gonna be reduced to 224. So now your model will be able to converge it in a much better way. Okay, in a much better way. So data preprocessing is completed. What we just did is we did all this, like we connected this and we read every image using CV2, and then we just resized every image. Okay, like it is, why it is showing only one image, because we have applied break function here. Okay, so like it will show one image only here. Okay, so see, image array, so this is your array right now. Okay, and you converted this is your image. Okay, sorry, not array, this is your image right now. You converted this into 224 by 224, and like this it will look. Okay, so now let's prepare our model. Okay, I hope people or you will not get confused, like what is img array. I'm just giving a name. Okay, or let's give it old image. Okay, like I hope like nobody will get confused what is ing array. Okay, array is something to store data and all, okay. So I'm just renaming the name. Okay, that's all. Yeah. So now let's do data preparation. Sorry, the model preparation. Okay, the last thing of training. So let's prepare our model. Okay. So as we have already imported TensorFlow, let me take it from here. Okay, directly. Like so that I just want to keep everything like in a separate way. So from tf dot of from tf dot keras, what version of TensorFlow you required? 2.2.4. I have GPU. Okay, so tf dot keras dot models. I'm gonna import what models I have right now. Sequential, I guess. Sequential. I think tf.from no model mtf. Yeah, from tensor. I think I need to write full name tensor. Yeah, sorry, I get stuck in the very basic thing. So now sequential, and here I need to write. I'll explain everything. Okay, don't worry. Image dot preprocessing dot image. I'm gonna import image data generator. Okay, like it will generate more data in a very basic term I'm explaining. Dot layers. Okay, I'm gonna import this dense layer, distance, and what all the layers we have. Activation, I will explain you. Okay, everything, don't worry, I'm going to explain you. I need dropout layer. Will I apply dropout? Okay, let's see, otherwise I will remove this. Dropout, flatten, and batch normalization. Will I even, I don't know, I'm getting good results without them, so okay, leave that. I'm getting good results without them, so if you need you can apply. Flatten. Okay, uh, and I need one more thing called convert 2D. mm, mm, Convo 2D. Okay, so now uh, yeah, max pooling also. Okay, max pooling 2D. Oh, max pooling 2D, and dense drop out active. Convo 2D. Okay, so now from I think hmm, 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 so keras dot applications. I'm gonna import not sorry, not on from application, again from models. Okay, again from models, let me just paste it here. From models I'm gonna import oh damn, what I'm even doing, not from models but from callbacks. I'm so sorry for that. Okay, callbacks, I in my like right now from where I'm seeing, it's very messy code. I need model checkpoint and early stop. I will explain you. Okay, I'll explain you, don't worry. Early stop. So we have sequential, we have callbacks, we have pre-processing, and now we have layers. I think that's enough. Yeah. Alright, okay. So now let's make your own model. So now let me test if I have GPU available. If you don't have GPU available, okay. So I have given the pre-trained model, so you can test it using that. True, it's available for me. Okay, and if you don't have available, then it's okay. You can't do training like with that fast, like with that speed. But I have given you pre-trained model, so you can, you know, you can do your testing. You can do everything. So now let's use this image data generator. Okay. So now training data gen, I'm just giving training data generator. Okay, I'm giving a variable name, and let's apply this image data generator to generate more image on the training data. First of all, rescale. What is rescale? Not only the size is very big, okay, but see the pixel values ranges between 0 to 255. Okay, so it's very huge for the model. Okay, so what we are going to do, see, for some image it happens. Okay, for some image the uh, you can say not only the size, like we have resized every image, but the pixel values changes a lot. Okay, some images are black, some images are very white, so it will be very difficult for the model to train. Okay, so we rescale everything, the whole pixel value, we divide them with 255. Okay, we divide all the image their pixel values with 255, so that it can come into a particular levels, means all the images their pixel size should be in a particular range. Okay, so that our model can converge better. This is called normalization. Okay, and let's generate more data by shear range. Like we just rescaled all data. Okay, now shear range 0.2% means, see, this is right now, this is my image. Okay, this is my image, it will shake it like this, okay, by 20%, and boom, boom, the next image will be generated. It will zoom. Okay, you can read the documentation, what are the features you have. Okay, you can do many things here. This is the power of Keras. Okay, Keras API, and see, so, and you have this like zoom range, shear range. Okay, this, see, vertical flip, horizontal flip, you have many things. Zoom range again 0.2, boom, next like horizontal flip true means this is your image and it will flip it horizontally, and boom, that's your another image. Okay, vertical flip true. Okay, that's all. Okay, so now we don't only want train and test, we want the validation folder also. Okay, like how we, our model gonna validate, like how the training is going on. Okay, so validation split means what we're going to do, this is our training, images, right? So we're gonna take the 20% of them for the validation. Okay, so that, like, of course we should have something like how our model is performing, we should validate, like, okay, so, by matching our results with the validation data, and now later on we can test on the test data. Okay, so now this is our data generator, like this is how our data will be generated. Okay, let me name this, rename this as data gen. Okay, not the train data gen, but just the data gen. And now the train data generator, okay, train data generator and validation, or in the short form val data gen. Okay, data gen means we're gonna use this data gen, okay, for the training and for the validation images. Okay, so now data gen dot, in the data gen you will find some, you will find one function called flow from directory. Okay, and in this you need to give some parameters like the directory name, the target size, what is your image size you have given, like you want to give, of course 224, right? A color mode by default is RGB. Class mode categorical, you can search like what is like our, we have a categorical project, like we have 4 categories. Batch size depends on your PC configuration, laptop configuration. It's like I always give 16. I have 24 GB of RAM, 4 GB of graphic memory. Earlier I used to give 2. Okay, no, don't laugh. Okay, so flow from directory, the directory path. Okay, like the training directory path. Just copy this. Okay, see, we will only do for the training and validation. We will not do for the testing. When we will test, then we will do rescaling and resizing. Okay, so wait, let me again give it in the inverted comma and put it R. Okay, this is your training folder, and what again we need to give the target size. Target size, we have defined what? Image size, that is image size cross image size means what? 224 by 224. Okay, batch size we need to give, that is 16. I am giving. If you get memory exhaust error, you can reduce it, okay, by 8 or just give it 4. You can give 2. If it's still making problem, means you are gone. Categorical, by default it's categorical, but just to let you understand. Subset, this is important. Subset, this is a subset for the training. Okay, like means what I mean is, let me just copy this whole. Okay, copy this whole, and for the validation, okay, see, for the validation everything will be same. It's just gonna be validation. Okay, means from this data gen, okay, 20% we are taking for the validation. Okay, folder will be same because we are taking from the same folder. Okay, and 80% we are keeping for the training, 20% we are taking for the validation. Let me run this. What's the problem? Target size is not defined. What? Oh, target size is equal to, sorry, is equal to image size cross image size. Okay, found 1458 images belongs to 4 classes. Found 363 images belong to 4 classes. Means 1458 images for the training, 363 images for the validation. Okay, testing images are different. Okay, testing images are here. This test one, this is different. Okay, I'm talking about training and validation only. So here you go. And yeah, in my old project I got 1457 images. So if it's varying for you, just do cross check because it's varying for me also. But all right, now we have our image data like ready. Okay, so now this was model preparation. Okay, model, now this was not, model preparation is going on. Okay, so now let's prepare our model. See, model is equals to let me model is equals to sequential. Sequential is what? It's a very simple feed forward neural network. Okay, let me just, now I'm going to explain you neural, now I'm going to explain you basics of neural network. Like this is not how neural network looks. Okay, like we just show like how in this way, but that's not how neural network looks. Okay, so see, the very feed forward neural network means a very simple neural network we are going to make. Okay, so sequential, you can understand that way. So model is equal to sequential. So now in this model we are going to add layer by layer. Okay, like we have defined a sequential layer. Okay, like so now our first layer is our input layer. Okay, this input layer, how many inputs we have? 4. Okay, so model dot add convo the convolutional layer. Okay, 2D, this is the part of CNN, okay, and see, convert 2D, and if you talk about this, okay, like what convert 2D, I am not able to get convert to D, it's capital D, okay, convert 2D. Now we need to give some basic parameters, okay, uh, mm, like the input shape, okay, 28 cross 28, 3, and how many channels are there and all, okay. So yeah, so the filter size, you can give it 128, you can give it 256, 64, okay, it's like the how many how to explain, I don't know, like how many neurons should be there, it's something like that, okay, you can understand how many filter size, you can see it's a filter size, okay, how many neurons should be there in the first layer, but it's an input layer, so it's all right, okay, um, but with attached to the input layer, okay, with attached to the input layer, how many neurons should you want here, okay, it's like that. So 64, and the kernel size is the filter size is 3 by 3, okay, filter size is 3 by 3. See, okay, let me just show you now, neural network, or should I go for VGG architecture? Okay, it's better, okay, this this is also, you can, the first layer, okay, the first layer we are defining the input layer, okay, and it has a activation function of ReLU. I am just going to explain you like what is the activation function and all, okay, don't worry. Activation, I think we have defined activation, I have defined activation is equals to ReLU, okay, ReLU, and ReLU, and only one thing we require is padding, okay, leave that, padding is by default, I think it's same, just give me 1 second guys, states padding same, and one of valid or same, what is by default, channel first, okay, all right, ReLU, okay, the file which I'm going to give you now, it's going to contain little more parameters, okay, input shape by 224, like I will see 224, this is the input shape, okay, of every image 224, or image size by image size by 3, you can give it, okay, like let's just give image size by image size, like as we are giving only this, okay, image by 3 channel, right, 3 channel, we have RGB, and what is this 3 RGB, like gray, we have pics of, like we have RGB photos, right, we are not converting it into gray, otherwise it would be 1, okay, if it's a gray images, but it's a color, so RGB, so 3 channels, right. What is this activation? ReLU, uh, ReLU activation, it's simple that, see, in the neural network, okay, in the neural network, if I show you, this is, can I even show you, just give me a second, my net speed is slow, okay, neural network, okay, just taking an image for you, or anything, any image, okay, see, one information needs to pass through other neurons, okay, this image I hope you can see, but it's all right, one information needs to pass through other neurons, okay, but it might be possible that that information, the confidence is very low, you can say, like that information might be false. Okay, so we set a kind of threshold value called activation. I am just explaining in a very simple way. Okay, we set a threshold value called activation, means if it, if like it's this ReLU, okay, this ReLU is and there is a also called sigmoid, okay, like what we are going to use softmax right now. Okay, but this ReLU, okay, if it's negative, then it's like 0. If it's less than 0, okay, then it's gonna be flattened, means no data will be passed. Okay, if it is negative or 0 or less than 0, you can say, then no data will be passed. And if it's 1 or if it is greater than 0, then only the data will pass. This is the threshold value of ReLU. Okay, when you will learn deep learning, you will understand in a much better way. Okay, means it's a threshold value. If it's 0 or less than 0, no data will be passed, else it will get passed. Okay, like you can see max 0, else it will go. Okay, so this filter, this is filter size. You can write 100, 200. Okay, filter size, like filter size external neural network. You can read about it. Okay, you can give it to any, you can give it anything. Okay, the filter size. Okay, I think okay, see, 3x3 filter, this 3x3 filter will go here, it will extract the features in the images. Features means this simple thing. Okay, this features, this features, this feature, this features. Okay, and of course now then only it can process this are 3x3 filters. How many filters will be there? 64, you can say. Okay, so activation function ReLU input shape equals to this is the input shape 224 by 224 by 3. Okay, and there are other things like padding, stripes, you can do that. Now model dot add max pooling to D, okay, of 2x2. Now what is this max pooling 2D? Okay, what is this max pooling 2D? See, BGG architecture, I think I have shown. See, okay, see, what is this pooling? What is this pooling? Okay, like it's loading. What is this pooling, right? So, see, if I just come here, okay, see, our image size 224 by 224 is 64. You can say like 224 by 224 by 3. Okay, I have taken the standard version of in the standard image size what we use in VGG16 architecture. Okay, 224 by 224 by 3. This is the image, and we have filters of 64. Okay, like 224 224 by 64 filters we have. It is extracting the images. Okay, now this red box, this is max pool. What is this max pool? See, if we take every data in the image, then model training will take very long, or it will even get failed. Okay, so what is max pooling? We don't need all the data. We don't need all the data. Okay, like this is the image, let's say. Okay, there is also called average pooling. There is another thing called a mean pooling, that is for minimum pooling. Okay, like I have never used mean pooling. Okay, so this max pooling. See, 2 cross 2, 2 cross 2, 2 cross 2. See, this is the image, the pixels you can say, or the data of the image. Okay, so 2 cross 2. Okay, so this pad, this max pool 2 cross 2, what it will do is, first 2 cross 2 means it will go here, and in this 2 cross 2 matrix, what's the maximum feature? This 9. Okay, so it will extract here. In this green region, what's the maximum feature? 7. It will extract here. In this 8, it will, in this 6, means it will leave all the data and it will only take the maximum data only required maximum feature further for the training, okay, for the training, so that our model can do faster training, or you can say it can converse better, okay. Otherwise, you know, if data is too large, it's bad, okay. Like see, max pooling is attracting, sorry, in extracting the maximum feature like this, okay. So max pooling 2D, and here you go, and mm, similarly, let's copy this, and I'm just gonna, what I'm gonna do, uh, 2D, and there you go, okay. So if I go here, okay, so I have given 64 filters and a max pooling layer, okay, a max pooling layer, then the image size will get reduced automatically, okay, it is getting reduced, okay, like here, okay. We are not going to do our image size, we have defined 224 by 224, okay, by 3. 3 is just a channel number, then 64 filter, this is the filters, okay. So first of all, convo 2D, that is convolutional 2D layer will extract the feature, then max pooling will extract the maximum feature, then again convo 2D will extract the features, okay. So again we have just copy pasted, and there you don't need to change anything, okay. There you don't need to change, we are making custom model, okay. I am not copying that VGG 16, okay. Again 64, you can increase this, okay, you can increase this, like here also you can it, like 128, 256, 512, let's increase this now, 128, okay, just like VGG 16 model, this is VGG 16, you can read about it, okay. 128, 256, I'm just increasing, it's experiment and run, okay. It's not like you ask me how did you know it was best, no, I just did experiment, that's all, okay. Again one more model.add 256, and it was 512, so you can keep it same, okay, 256 again, or you can keep it like 512, it's up to you if you are getting good accuracy. And yeah, of course, input shape you only need to give in the first one, okay, the first one, put shape and the first one only, okay. Please don't do this mistake to give input shape every time same, okay. The first one, all right, everything is fine enough till here. And now at last, like after, you can add multiple layers, but don't make your model too big, it will be bad, okay. Model.add, and at last flatten it. Flatten it means like this, see, oops, sorry, flatten it means, see, this is your model, and now press it means flatten it, okay, means so that your model can see all the neurons in a much easy way. So I think this is fine, okay. This is your model, like just say na, like this is your all the model, all the layers, and this is a flattened one, okay, this bigger one, the flattened one. Here you can, this is the last step, this here you can, like here the model can see every neuron, you can say, okay, if you just flat it like this, okay. This is the better example. You did max pooling convert 2D, max pooling convert 2D, and then you have flattened all the layers, this you have pressed it, okay. So now model.add the flatten layer, flatten layer, okay. And now at last model.add, after flattening it, okay, after flattening it, you need the last 4 neurons, the last layer which contains the output neurons. How many output neurons does we have, okay, like after this we flattened it, now we gonna connect to the last one, means like this, see, we connected many hidden layers, like this is the hidden layer, this is the hidden layer, right. Oops, this is the hidden layer. After that we flattened it, at last, okay, like and then we need to connect this into with the last output layer, which contains how many neurons? 4, you can say. Okay, model dot add 4, because we have only 4 outputs. Model dot add dense layer. This is called dense layer. Okay, at last dense layer. Activation function here. What activation function we will use? Softmax here. We will use sigmoid when we have only binary classification. But what is softmax? If you see, what is softmax? See, you have many activation functions. Okay, sigmoid and all. Sigmoid we will use when we have only binary, means we have only 2 categories. So let me just directly write here softmax. Softmax is simple, like you have multiple categories. Okay, so based on that, okay, it's the threshold value is 50%. Okay, means if your model thinks, okay, that I am more than 50% sure that it is healthy, okay, then your prediction will come as healthy. If your model thinks that I am 80% sure, means more than 50% sure that that it is having scab, then your prediction will come as scab. Okay, so softmax activation function, we used ReLU here, and now we are using softmax. Okay, so at last either we use sigmoid or we use softmax. Okay, so now let's compile the model. Okay, like before running we need to compile the model. Okay, before training. Why it's always going here, I don't know. Okay, so model dot compile. Okay, model dot compile. So in the compile, what we need to give? I think I am doing something wrong. It's not even showing the output. Compiler, COMPILE. Okay, let me run till here. In value model dot add here. Three. Where max pulling 2D 2 cross 2. Oh, I think I need to give it like this. 2 cross in a tuple. Yeah, like this. So it's like this, like this. Okay. No. Let's do sequential model dot add convo 2D. Okay. Convo 2D 64 3 cross 3 activation ReLU input shape 24 oh yeah, I think I was not using this. Oops. Yeah, I think I need to apply it here also, right? Here, here, and here. EUF while parsing here also. Okay, and I don't think I need to put 2 brackets here. Yeah, I don't think I need to. I was just doing a stupid thing to make my audience confused. Okay, so now model. Let me add in the same cell. Okay, compile the model. Okay, so model dot compile compile. It will take some parameters like optimizer, loss, and matrix. These 3 things. Okay, let me just directly copy this. Dot compile optimizer. Okay, you can give Adam optimizer. Okay, Adam optimizer, and by default its learning rate be 0.001. What is the learning rate by default? They give learning rate should be small enough. I don't know what they give by default. Okay, so optimizer is Adam. What is optimizer? If you know deep learning, it's optimizer for the back propagation. For the back propagation, okay, when your model optimizer in C or say NN. Okay, so for the back propagation, your model need to decrease the loss and increase the accuracy. Okay, so let it load. Okay, or it doesn't. Okay, see like this. Okay, so your model need to decrease the loss and increase the accuracy. Okay, so it's like right now Adam optimizer is the best one right now. Okay, right now Adam optimizer is the best one. Okay, Adam, this pinkish line, this one. Okay, so Adam optimizer loss, what is the loss? Categorical cross entropy. Okay, if it's a, because it is having multiple categories. If it is having only two categories, then binary or uh, binary cross entropy. Okay, categorical cross entropy. Okay, and the matrix accuracy, simple, right? Accuracy, that's all. Now model dot summary, that's how your model looks. Now see, this is how your model looks. Okay, this you have parameters and input shape 222 by 220 by 64. What am I doing wrong? Did I what I have given? 224 I have given. So it's taking 222. Okay, let me run that shell again. I think I was just explaining, and that time I. Okay. Oh, can anybody help me? I'm stuck. Mm, mm. All right. So I'm giving one more parameter called as padding. Okay. Padding is equals to same. What is padding? Is simple, that padding in CNN. Okay. Oh, sorry. Padding is simple, that see, I'm not getting good image. See, in a very simple way, that it creates another layer. Okay, and then filter size goes, filter 3 by 3 filter goes, and the max pooling goes and all. Okay, it extract the features. So in that case, what happens? See, if you don't have padding is not equal to same. Okay, if you don't give padding not equal to same. Okay, see, mm, see this. Okay, without padding your image size will get decrease. Okay, so when I was running this, okay, padding, oops, sorry, I always do this kind of See this, we have given image size crossed by image size, okay, which is 224, but see here, image size in the first layer is decreased 222. How? Because of the padding, okay. Like see, we need to find, like we need to define what is padding, okay. Padding means if you don't give arguments for padding, okay, like without padding your image size is getting decreased. See, 3 by 3 layer of filter applied here, applied here, this matrix is getting reduced to this, 5 cross 5 is getting reduced to 3 cross 3. But if you give padding is equals to same, then this either, see, it's like padding will not affect, okay. Any better example? Any better example? Mm, see, without padding, your image size is getting decreased. Okay, like here we have not applied padding, so our image size was like 224 by 224, but see, it's getting reduced to 222 by 222 and like that. Okay, so if you apply padding, by default it is valid, okay. So if you apply padding is equals to 0, it will, or padding is equals to same basically, okay. So it will generate this kind of wall, okay. So now if you apply kernel filter here, okay, your image size will not get decrease, okay. Like I just found out in the Stack Overflow, without padding, if it's valid inputs, and this last two gonna get dropped, okay. So image size will get reduced from 1 to 13 to 1 to 11. But if you give same, means 0 padding, so see, 0 and the pad of 0 means the block is getting applied and your image size will not get affected, okay. So padding is equals to oops, padding is equals to same, okay. Let me just copy this and just paste it here with a comma, and all right. I think padding, oh, where, I think I'm doing the right way. PADDING in the convert 2D. Padding. Wait. Let me just cut it and paste it here. Padding is equal to same. Then yeah, under this here, and under this here. See, now your image size is not getting reduced. See, this is your model summary, okay. The parameters you can see, we have around 4 lakh parameters, okay, like it's huge one. The last thing to define is, before training is starting, before the training gets started, checkpoint and early stop, which we imported now. So checkpoint is model checkpoint, which we imported now, model checkpoint and early stopping, okay. This is for the callbacks, means checkpoint means save best only, okay. Here we need to give file path and the monitor validation loss, means once the training starts, it will evaluate every epochs, every epochs, okay, every epochs. And let me save this in the models itself, okay. Models folder, and under that I've already have a model, So let me rename it as apple 2.h5, the charac extension. So for every epoch it will see the result, and in whatever epoch, okay, in whatever iteration, the accuracy is higher, it will save that only. Okay. So validation loss, this is the parameter. Mode is equals to minimum, and save best only is equals to true, and verbose, the font size basically is not font size but 1. Okay. And one last is early stopping. Okay, so early stop is equals to early stopping monitor. It's gonna monitor with the validation loss. Is what does early stopping means is, once if the accuracy is not increasing, okay, if the accuracy is not increasing, then minimum delta means you can say and wait for patience is equals to 7 epochs or 10 you can give. Okay, means in the 10 epochs, if the accuracy doesn't increases or the validation loss doesn't decreases, okay, we are given for the validation loss. Okay, then stop the training and restore the best weights true. So callbacks equals to checkpoint and early stop. Okay, so monitor 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 monitor, it's monitor. All right, let's start the training. Model, you don't need to store this in the variable, but we need to plot the that now accuracy and loss. Model dot fit, that's how we started training. Model dot fit generator. Okay, here we need to give some, here we need to give generator, it's all things. Okay, so let's give them line by line. Train generator or data gen. Okay, train data gen. Train data gen, this. Okay, this is the training folder or file, and this is the validation. Let's give them both. Train data gen. Okay, generator is this, and what else we can do here? What else? Validation data. Validation data. What is validation data? Is equals to well data gen. Okay, well data gen. How many epochs means for how many iterations? You can set it 50, 100. I'm setting to 30. Okay, validation. Uh, Validation or okay, first let me write steps per steps. Why it's not showing steps per epochs? Okay, steps per epochs. I'm giving to, let's say, whatever the amount of training data we have, divide that with batch size, that is 16 batch size. Okay, and the validation steps, whatever it you have in the well data gen, divide that with its the batch size. Okay, and what is the callbacks? Callbacks is equals to callbacks. Okay, that's all you need to give. And your let's see what error we get. Batch size is not defined. we have defined best size, I think. Oh, best size. Oh, we have not defined. We have just given now. So let's give it again here. Okay. We have defined in the program under that function, so it is not taking that. And the iterator. Okay, we got a problem that directory iterator and int means. Okay, so we got an error. Yeah, it's dot samples. Okay, dot samples. Is it samples? Okay, samples means in this data the number of samples divided by 16. That's your steps. Okay, and now we got one more. It's categorical. Oh, spelling is wrong. Cat I said I'm so bad at spelling categorical. I'm just gonna Google it. I'm very bad at spelling. I'm very bad at spelling. Um, yeah, it's right. Okay. Uh, okay. So see, my model training started. It will make a file name apple2.h5. Let me remove that and see. Yeah. So see, the loss, it should decrease, accuracy should increase. Okay, see the 91 images, sorry, 91 steps per epochs. Okay, loss should decrease, accuracy decrease, and if it's not happening, then you need to change your model, or you need to improve your model. You need to experiment with your image size. You need to experiment with padding, strides, many things. That's fun, that's really fun. You can change the optimizer, but Adam is the best right now. See, you can check for the learning rate, like if it should be like 0.001 and all. Okay, or what's the learning rate right now by default we have defined. One epoch is completed, and let's go for the two. Okay, the two loss getting decreases. See, 1.27, accuracy is getting increased. Okay, okay, so let me pause the video. See here, the accuracy doesn't increases, like it's due to early stopping. Okay, like validation loss did not improve, like it is not decreasing, but accuracy is not increasing. Okay, means our model is not performing well, it's not training well. Okay, what's that? Okay, so what should we do? First of all, what should we do? Okay, we can try to reduce the filter size, like, or like just saying, okay, we can try to have another activation function. We can try for multiple amount of things, like we can try many things. We can try to change the image size. Okay, so in my case, what I will do is, as last time in my old model where I was getting good results. Okay, so in that I have this 64 only. Okay, and in last I have only 128, so I'm just gonna go for that only. Okay, it's up to you what you try. Okay, yeah, it's up to you what you try. So let me just experiment, because when people ask me what should be the best model to train, and I say I don't know. Okay, it's all about experimenting, it's all about experimenting and learn. Okay, Adam, what's the default? See the total, and Apple 2 has been created. Okay, here Apple 2 models, Apple 2. Okay, this Apple 2024 I created because the image size was like, I just nomenclature it. Okay, Apple. Let me create 3. Okay, this time, like, or 2, it will overwrite it. Okay, let me delete that. It will basically overwrite it, don't worry. Okay, okay, now let's see for model performs well or not. Okay, now it's like, is the first epoch, what do you say this? um okay, it's going on. Have मैं दीवाना. See, the accuracy is increasing, but it's just the first epochs. Result we can see in the next 2 to 3 epochs, like, you know. Okay, so now we are going for the second epochs. Accuracy, the last time is 34. It's increasing. It's increasing. Seems so, but it's decreasing. It's increasing. So we can only say with more number of epochs, let it happen. Otherwise, I'll try different thing and I'll see what I can do. Okay. Mm, what wrong I did? I don't know. In last I initialized kernel initializer also. Okay. With the uniform distribution, learning rate was this. Loss. Adam. What is the default learning rate? No, it's not increasing again. It's same. It's like same pattern. See, 0.3, then 0.2, and see it's 0.37. But let's see for this epochs. Okay, like 3. This is the third epochs, and I hope it does. Okay, it's decreasing again. Okay, increasing, decreasing. Let's see, because validation accuracy 0.32. Validation loss improved from 1.27 to 1.23. Okay, let's see, and this is the accuracy, this is the loss, and last time the loss was 1.23, this time it's 1.2354. Let's see how much, because seems so. Accuracy increased. Validation improved from 1 to 1.23 to 1.18. Accuracy is also increasing. So yeah, this model is working for us. Fine enough. Fine enough. Let's see for this epochs, and I'm gonna pause this video. But it's again decreasing, increasing. I don't know what's the problem. Okay, it increases very slowly now. I guess, yeah. 3, 8. Let's see for this time. Last time it was 1.18 validation loss. So what is accuracy validation loss? Did not improved. Okay, take care of this. So okay, let me pause the video. So even after doing modification in the model, we are not getting that much good accuracy, okay, and that much decrease in loss. So one more thing I would like to do here is Adam learning rate is equals to 0.001, because in my old model I kept it same, I guess 0.001 in this way, basically 0.001. Yeah. So now I'm gonna see, well, I think that's how we initialize, right? Or syntax. Let me just check the syntax. Is this the same way, or learning rate? Uh, Adam Keras thought optimizers thought Adam. Okay. Let me go for Adam. Optimizer is equals to um let's just say TensorFlow, oops, Tensor or TensorFlow or TF or whatever, TensorFlow dot Keras dot let's say optimizers dot, in that you will find Adam. Okay, but why it's not auto completing it? Uh, that's how you can write dot optimizers dot Adam, and under that you will find uh, learning rate. Okay, learning rate is equals to 0.001. Last time I guess, yeah, 0.001. This is my optimizer. Okay, that's how I'm calling right now. I'm just not giving Adam name, I'm just literally calling it like TensorFlow, then Keras, then optimizer, then Adam. Okay, like from TensorFlow, under Keras, under optimizer, Adam, and its learning rate. Learning rate is basically how fast or slow your model will learn. Okay, if it's too fast, it's not gonna converge better. If it's too slow, it's not gonna converge better, or it's gonna converge very slowly. TensorFlow, what happened here? TensorFlow is not defined. I guess I did. Compile the model. TensorFlow is not defined. Now what's the problem? TEN, or I guess it's STF. I guess this attribute error. Optimizer, really? Uh, it's optimizers. Sorry, guys. Okay, so we are good to go now. Let me delete this one once again. Not this much. Models equal to, okay, and yeah, as it was not improved, so now let's see. Okay, with I don't know what's the default learning rate, but I just kept this one, like where it is 0.001. I don't know what's the oh, I need to restart this again. And now let's run this. So now it's going on. Yes, it started. Let it complete, and then we're gonna test our model. Okay, so model training has been completed, and so loss is only 0.18, accuracy is 0.92. If we train it for, you can say, validation accuracy is 0.93, validation loss is 0.19. If we train it for next tiny pole, it will show better results. Like if you plot them, mm, if you plot them, like oops. loss, mm, mm, accuracy, or in a simple terms, accuracy train is equals to model history, oops, model history and accuracy, and what we have, accuracy validation is equals to model history, and we have validation accuracy. Like it should be like this, okay, VAL then accuracy, right? What we have there, epochs, how many epochs for we trained, um, epochs, it's an in a range between 1 to 31, means total 30, right? Now let's just plot them, plt dot plot, um, plot epochs, like for the whole range between for 1 to 31, means before 31 means 30, right? So oops, accuracy train, it should be green, okay, and label this as training accuracy. I'm gonna copy this epochs and this one accuracy VL, it will be in blue color, and train validation accuracy, validation accuracy. You can give a title plt dot title training and validation accuracy plt, okay, leave that, plt dot show. Now what's the problem, history object not stable, why, history, model history dot history, sorry, model history, and under that you have history, right? Yeah, and model history, dot history, validation accuracy key error, accuracy, okay, accuracy, now epochs, why I'm doing so much error, okay, see this, see in the green color how training accuracy is going on and how validation accuracy is going on with it, and it's showing means a pretty good result. plt dot x label, in the x label it will be epochs, and plt dot y label it will be accuracy, okay, and one more thing, plt dot legend, and okay, all right, see here plt dot legend, what it does, it put your labels here, okay. So let me just copy this and just paste this whole, and now it's time for the loss, okay. So loss and validation loss, it should be loss, okay, then loss training loss, oops, should copy this word now. Loss, loss, loss. Okay. See how loss is decreasing, error is decreasing. Okay, like in the back propagation, how it's going on. It's pretty good. Let's test the model for the one particular image. Okay. um, making a single making the prediction on a single image. Okay. So for here, from TensorFlow dot keras dot preprocessing, I'm going to import image. Now test image is equals to image dot load image. Okay, so from image we are loading the image. Which image? Test image. Okay, so first of all, what's test image? No, we need to define that. What's the test image? Okay, so test image is equals to, what's the test image? Let's test on anything, na, like uh, mm, images and test. Okay, I don't know what the test 0 is, because if you see in our data set, okay, we don't have any labels given. Okay, so it's a very unseen data. You can test on training data also, and you can match with that. Okay, like see this test 3, this is test 3, looks very healthy. Okay, so uh, let's test on that if it shows healthy or not, and test 3.jpg. Okay, and put R here. So load image, this test image, just load it, test image. Okay, then you need to convert this into array. Okay, like right now you have just, see, you can load like this. Okay, but you need to convert this into array. Okay, test image is equals to image dot img2 array. Okay, test image. Now oops, what happened? Loading, sorry. Okay, see, that's how you have converted this into array. Okay, but you need to resize it, you need to scale it down also. So rescaling, first of all, image is equals to divide every picture of this image, this test image, by 255, and we are storing it back into test image. So see, oops, invalid continuous byte. Why? Oh, why it's always showing me error? I don't know why it's always showing me error. See, that's how we have divided. See, earlier it was 147, 140 and all, but we have divided with 255. Why? Because the highest pixel size is 255 for any image. Now, test image is equals to np dot expand dimension. Okay, expand the shape of array. Test image and axis is equals to 0. See, uh, right now its shape is 3 dimension. Okay, 1 2 3, and if I do this, I have no idea what it's okay. Now it's 4 dimension. See, 1 2 3 4. So what expand dimension do is it say this convert to now this for the prediction. Okay, sorry, not converted, but for the prediction in CNN or like in general, we need four things. Okay, like if I show you this input shape, okay, like see na input shape we have given na input shape, okay, like here, okay, image size with image size and the channel number, and one more thing called batch. Okay, this the batch size. So right now for prediction we are only giving one single image. Okay, so that's why only we are expanding only one batch size. So earlier it was 3 dimension and now it's fourth one with the batch, means the batch of single image. Okay, that's all. The pre-processing is done. We have loaded the image, we have converted into array, we have scaled it down, we have expanded the dimension. Okay, yeah, one more thing, sorry, I forgot, we need to resize it. Here load image and resize it, no. So target, that's how we can resize it. Target size equals to 24 by 224, or image size with image size. Okay, why it's even showing me error every time? I'll have a look. Okay, I need to, yeah. So now its size is 224 by 224, like its size is reduced. Okay, and now let's predict. Okay, so result is equals to model dot predict this test image. Okay, so we will get 4 output. Basically we will get what, 4 output. Okay, result. But okay, let me check this, why I'm getting this error. See, we got 4 output, and the 4 output is the, like, how to know, see, in our usually, like, how we trained our model using these 4 categories. Our model, see, when we gave now, when we gave this one, um, when we gave this now image data generator. Okay, this training data, from where it will take, from the training folder. Class mode is categorical, means when the model will go there now, it will see 4 categories of folders. So now this is the labels. Okay, means this is the structure, this is the label. Earlier whole images were into one folder, but now we have divided into 4 folder. So see, the first one is healthy, the second one is multiple diseases, third is rust, fourth is scab. Okay, so now see which is getting the highest probability. This one, the 0th index, okay, 0.96, and which is the 0th index, healthy. Okay, so that's how it works. So our model is trying to say that I am 0.96% sure probably that this is healthy, that image test 3 is healthy. Okay, okay, so um, categories is equals to healthy, multiple, this, just giving name. Okay, multiple diseases, you don't need to give underscore here. Okay, scab, let me just give, like, you don't, if you don't get confused. Now this is the categories. Okay, so in the categories I want to show the result. Okay, like how it will come, see, there is a term called argmax. Okay, there is a term called, and I'm getting error every time, no, from here. So here you go. Okay, so I don't need to run that shell again. uh, Print result and the maximum. Okay, so the maximum result only print. Arg max result is equals to 1, axis is equals to 1. Okay, so means the print the maximum. See, the 0th index. Okay, argmax function does what? It prints the index of the maximum probability. Okay, so 0th. Now we just want, let me copy this here. Okay, yeah. So on the integer, if I don't give x is equals to 1 here, what will happen? Yeah, only 0. Okay, so I don't need to give x is equals to 1. Healthy. Okay, so what this is doing, that categories, this is indexing, right? If I give first index, then multiple diseases, second, then rust. So it's like this. It's like this. Okay, argmax result, like what is np argmax? 0. So healthy. And to make it more image result, image result, like which image we called? Image dot open. From PIL we are opening test image. Okay, and we will plot it. Image result is equals to plt dot imshow image result, and plt dot title, the dot title and title gonna be this only, this. I'm just gonna copy this and plt dot show, and so now what's the problem? Read. Well, oh, okay, okay, okay. Let me put this one here. Okay, because further we are converting this test image with, you know, many things. So all right, so once we load the test image, it will store this here, and later on we can do our preprocessing. So now see, it is healthy. Okay, all right. To confirm this, you can even take it from the training folder also. Okay, like from scab I am taking. Okay, like yes, test it on the training set also you can, like so train 8, I guess it was in the scab, train 8, yeah. So see, scab, like we know na the labels of the training. Okay, so we can easily say multiple diseases, all the multiple diseases, let's say 25 now. Let me take 25 only, image number 25. Train 25. All right. I not found. Oh, it's not scab. Multiple diseases. Yeah. And the last for the Rust, like it's showing us the good results. Rust train 3 is there. Mm, Rust train 3. Okay, guys. So yes, okay, it's showing good results. Okay, so this is done. I'll upload web deployment tutorial also. Okay, you will find link in the description. Okay, so I think everything is done. If you have any problem, DM me in Instagram or leave the comments. Okay, and if you find this tutorial useful, please leave the comments. It really helps me a lot. Subscribe, hit the bell icon. Thank you very much.